Hello class, welcome to Understanding Macro Models Lesson 3. This one is on the Keynesian model, and this lesson's quite long and there's some math in here. I suggest that you get a pencil and paper and a calculator and try to follow these models as I present them to you. Okay, so let's get started. So we call it the Keynesian model, but the truth is if Keynes hadn't have been quite so famous, if he had been a more ordinary economist, we might have called it the demand side model, because it really is about manipulating aggregate demand. The whole model is about managing aggregate demand, and then aggregate supply just follows whatever aggregate demand is doing. But because Keynes was quite famous, we don't call it demand side economics, we call it Keynesian economics, or the Keynesian model. Okay, so what is aggregate demand? Aggregate demand is just the total demand of all goods and services in the economy. You can think of it as its four components. There is what you and I buy, somehow all added up. We call that personal consumption. It takes the symbol C. Then to that you'd have to add up what businesses buy, and we call that business investment. It takes the symbol I. And on top of that you'd have to add up what the government buys. We call that government spending, obviously. It takes a symbol G. The only one that's really complicated is this last one, net exports, because aggregate demand would include things that foreigners buy from us, but we would have to subtract out things we buy from them because they would already be hidden up here in our consumption. So we net out things that we buy from foreigners because it doesn't represent our aggregate demand, but then of course things they buy from us does represent our aggregate demand. So the symbol is X sub n, net exports, and the formula is net exports equals exports minus imports. So this formula is kind of important, and I don't think I bring it to your attention again. Alright, so aggregate demand then is just the sum of all these things, C plus I plus G plus XN. Now what is aggregate supply? Well, aggregate supply is just the total of all the goods and services produced in the economy in 1 year. It's kind of like GDP. So aggregate demand is what we collectively purchase, and aggregate supply is what we collectively produce. They are abstractions. If you were to ask like an accountant to go out and actually estimate aggregate demand or estimate aggregate supply, they would have 1,000 questions about what to count and what to exclude. But it's just a conceptual concept. It's not a thing we can really measure with much precision. Alright, so here are the basic Keynesian rules without any algebra. So if it turns out that aggregate demand is greater than aggregate supply, that is that we are all collectively buying up stuff faster than it's being made, then production supervisors would notice that inventories are being depleted because they're selling things faster than they're making it. And then those production supervisors would adjust their production by hiring new workers. And when they hired those new workers, of course, output would grow, the economy would grow, and unemployment would fall. Now the opposite situation would be where aggregate demand is less than aggregate supply. In this case, we are collectively buying stuff at a slower rate than we are producing it. Notice how everything is aggregated up here. So in this case, production supervisors would notice that inventories are increasing because they're producing things faster than they're selling it. So warehouses are piling up with stuff, and then those supervisors would adjust things by laying off workers. When those workers get laid off, obviously output would fall, the economy would shrink, and unemployment would rise. Now the third situation was called by my old professor, he called it the knife edge case in his kind of broken Japanese thick accent, the knife edge case. The guy's passed now, but I still remember him. Where aggregate demand is actually equal to aggregate supply. So in this case, inventories wouldn't do anything because we're selling things at the same rate that we're producing them. So inventories would be unchanged, and production supervisors would take no action, and the economy would be in equilibrium. So this is the Keynesian model in a nutshell without any math. Alright, now notice that whatever aggregate demand is, if it's too big or too small, doesn't matter, aggregate supply adjusts. So this is an important feature of the Keynesian model. Aggregate demand is the thing that's driving aggregate supply. So in the language of economics, we call aggregate demand the exogenous variable because it comes from outside, external, exogenous variable. And aggregate supply is the thing that follows. We call it the endogenous variable. Now these are really great words, and I thought I would have a little fun with you for just a minute to help you remember these words and to use them in your everyday language. So you might remember this old movie, Field of Dreams, starring Kevin Costner. It was probably out when you were maybe 5 years old. And I saw this thing and I thought, it's the stupidest movie ever. But it's a great example of exogenous and endogenous variables. You might remember in an opening scene, the poor guy who's a farmer out in Iowa someplace hears voices. He hears these voices and he tells his wife, and really, the wife should have quietly packed up the kids and left. But no, she said, "Oh, sweetheart, it's okay. Do what the voices tell you to do." So he plowed under his corn and he built a baseball field because the voices told him, if you build it, that is a baseball field, they will come. That is, long dead baseball players will come. So what he did is he built this baseball field. This is actually where this thing was done. That was their farmhouse. He built this thing, and then these long dead baseball players came out of the corn and played baseball. So if you build it is the exogenous variable, right? The thing that you have to do, and they will come, long dead baseball players will come out of the corn, is the endogenous variable. Alright, so enough fun, I'm sorry. Exogenous and endogenous. Now let's build a very, very simple Keynesian model for the first one, and then later in this video I have a more complicated one. So let's start with aggregate demand equals aggregate supply, and then of course aggregate demand is simply C plus I plus G plus XN, right? This is it. U and I plus businesses plus government plus net exports. Now let's just assume in this simple model that exports and imports are equal. So if exports and imports are equal, net exports would be 0. So in this simple model, let's assume net exports is 0, so this term disappears. Similarly, in this very simple model, let's let government spending be 0. Like, let's just imagine some imaginary world where we all get along with each other and we don't need government. We just live neighbor to neighbor. We live in peace. Wouldn't that be nice? So in this kind of simple world, let government spending be 0, so that term disappears. Then aggregate supply, you might remember, can be measured as income. If you go back to that lecture on GDP, there was a second definition of GDP, which was it's the total sum of all the incomes generated in the economy, and that's how they get this term right here. Aggregate supply turns into income. So let me just clean this thing up a little bit. So we have C plus I equals income in this very, very simple first Keynesian model, because there's no government spending and there's no net exports. So yeah, I did that. So then aggregate supply is measured as income. I talked about that. And now if you think about this equation, what it actually says is aggregate demand, which in this simple world is just C plus I, is equal to aggregate supply, which is measured as income. Now, the consumption function, what does it look like? Well, in the real world, if you put income on this axis and you put consumption over here, the consumption function would probably have some positive intercept, because if you're alive, you have to eat, even if your income is 0. So even if your income were 0, there would still be some consumption. And it would probably rise pretty fast as your income began to go up, but as you got really, really wealthy, consumption would probably level off. I don't suppose that Bill and Melinda Gates get very excited if they find out from their accountant that they have an extra $1,000 that they didn't realize they had. They probably don't notice. But if you and I discovered an extra $1,000 that we didn't realize we had, we might be excited about it. So you and I might be over here and Bill and Melinda Gates are out there somewhere. So the consumption function in the real world probably has this shape. But in the Keynesian model, at least for this class, the Keynesian model assumes that the consumption function is linear. It makes the math much easier. Now you might think, yeah, but the consumption function in real life isn't linear. That's true, but if you just use the Keynesian model to talk about incremental changes in income, right? You're just trying to figure out, what does the Keynesian model say if we stimulate the economy a little bit or we contract it a little bit? It doesn't matter as long as we make these incremental changes. It doesn't matter if you model the consumption function as a straight line or as some kind of weird curve that's probably better describes what it looks like in the real world. If that defense is bugging you a little, then send me an email or call me and we can discuss it. I'd love to discuss it with you. Anyway, so the consumption function is drawn as a straight line. Now there's a couple of things that you need to remember. This little intercept over here is called autonomous spending. It is how much consumption you have even when your income is zero. When your income is zero, you still got to eat, you got to live someplace, so maybe you draw down your savings or you borrow from the future, but there will be some spending somehow, autonomous spending. And then the slope of this thing is, in economics, is called the marginal propensity to consume. If this were a math class, this would just be some straight line, and this thing over here would be called the y-intercept, and this would just be called the slope, usually the symbol m. But it's not. This is a Keynesian model, so this is autonomous spending, and this is the marginal propensity to consume. All right, so then the function of this helping line will be obvious a little bit later, but normally we draw this helping line through here, and it would be at 45 degrees. So at 45 degrees, whatever's over here would be equal to whatever's over there, because the 45 degree line would plot out 1, 1, 2, 2, 3, 3, 4, 4, and so forth. It'll be obvious in a minute. Oh yeah, so sorry, this is the equation for the consumption function. It's just modeled right after the equation for a straight line. Consumption equals the slope of the function times income. This is the symbol for income. I know it's confusing. I don't even know how it ever happened in history that the symbol for income, which is measured on the x-axis, the symbol for income is the letter Y. I have no idea how that happened, but it is. The symbol for income is Y. This is the slope, MPC, and this is the intercept, which is over here, the vertical intercept, autonomous spending. Okay, now let's work on the investment function. It's actually easier. The investment function comes from supply and demand that we did long ago. So this is the demand curve for investment funds. So these are potential borrowers. When interest rates really high, they don't want to borrow much. And these are the supply of investment funds. So these are potential savers. And so the interaction in the investment market of these borrowers and these savers generates this kind of equilibrium right here. So this would be the equilibrium interest rate, and over here would be the equilibrium level of investment. So we just take that equilibrium level of investment, let's just call it I0, just so we can name it. And I'm going to take that investment level, I0, and I'm going to put it in this graph over here. And then the investment function just comes straight out, because notice investment comes from supply and demand. It's not related to income. At least in the simple Keynesian model, it's drawn like this. Now the next thing to do is to put them together. So we have the consumption function, remember, from about 3 slides back. And now what we want to do is add investment. So here's how much investment there was. So when we add that thing, we just get a new line parallel to the old one. And this line is called C plus I. All right? And so in our simple little model that we're working on, remember, there was no government spending and there was no net export. So C plus I would be aggregate demand. And so if this line is aggregate demand, and this is a 45 degree line right here, this little spot right here represents the place where aggregate demand, which is measured over here, is exactly equal to aggregate supply, which is measured over here. So this would be Keynesian equilibrium in a world where there's no government spending and no net exports. All right, now here's where Keynesian policy comes in. In the Keynesian world, equilibrium just occurs where aggregate demand equals aggregate supply. It's not necessarily where everyone has a job. It could be that for everybody to have a job, we needed to be over here. Keynes would call this the full employment income. So we have an economy that's languishing here, and we really need it to get out here. And so Keynes would say we need to take action. And the action he wants to take is he wants to stimulate aggregate demand. That is, he wants to take this aggregate demand function and somehow push it up. So he wants to get the C plus I function to lay on the 45-degree line up here, right above full employment income. So he stimulates aggregate demand, right, and forces the equilibrium of aggregate demand and aggregate supply to move from here over to here, so that equilibrium lays directly on top of full employment income. So this little thing over here is called the change in investment in our simple world, right? We're going to increase investment. So instead of C plus I being here, we're going to have C plus I up here. And when we do that, it's going to move equilibrium. This is the older equilibrium income level, and this is the new one. So this little change in investment right here yields this big change over here in equilibrium income. That's the power of the Keynesian model. Now, this relationship between this little change in aggregate demand and this bigger change over here in income can be described as follows. The change in aggregate demand times the Keynesian multiplier, called K, will give you the change in income. So any change over here times the Keynesian multiplier will give you the resulting change in income. Now the Keynesian multiplier has a formula. It's equal to 1 over 1 minus the marginal propensity to consume. And in a minute I'm going to put real numbers in here and we can actually calculate one. Alright, so let's try a simple Keynesian math problem. So let's let autonomous spending be 150, the marginal propensity to consume be 0.6, investment be 250, and full employment income be 1,500. Notice government spending is 0 and net exports are 0, just as before. Now the next thing to do is to kind of plug these numbers in. So 1,500 full employment income is sitting out here someplace. Then let's see, autonomous spending is here, 150, right? Because this is the consumption function. This is the level of consumption when income is 0, so that's that thing. Then 250 was investment, that's this thing right here. So if that's 150 and this is 250, then this number right here would be 400, right? 150 plus 250 would make 400. Then the multiplier is 1 over 1 minus the marginal propensity to consume. So in this problem it would be 1 divided by 1 minus 0.6. 1 minus 0.6 is 1 over 0.4. And if you put that in your calculator, you should see that the multiplier is 2.5, right? 1 divided by parentheses 1 minus 0.6, close paren, should be 2.5. Now the way you do this in this visual representation of the Keynesian model is any number that's over here on some line, any number over here, times this multiplier gives you the corresponding number over here on the other side of the 45-degree line. So we know this is equilibrium right here, right? Because this is where aggregate demand equals aggregate supply. So this number was 400. So 400 times 2.5 would give me this number over here, which was 1,000. See, I did the math for you right here. Equilibrium income equals 400 times 2.5. So this is equilibrium income, but in this Keynesian world, full employment income is over here at 1,500. So we got a problem. The economy is languishing here at 1,000, but for everybody to have a job, it needs to be over there. So we can look at it visually like this. If we just bring a line straight up from there to this 45-degree line and then connect it over there, right? This number, let's just call it x. This number times 2.5 has got to equal this number over here, 1,500. So can you see that we could work backwards? You could take this number, 1,500, divide it by 2.5, and it would give you this number over here, which you can calculate. It'll be 600. So if that number is 600 and this number down here was 400, what is this little extra investment that we need? That little extra investment must have been 200, right? Because that's 600 and that's 400. And then the change in income that got generated over here is 500. Can you see that? Because this was 1,000, this is 1,500, so that would be 500. So again, now look at the power of the multiplier. A $200 increase in investment created a $500 increase in equilibrium income. It seems like magic. In fact, opponents of the Keynesian model will actually call it that. But in the Keynesian world, no, this is what happens. And so I want to explain to you how it happens. So here's another formula that you can use to get the same answer. You can take the change in aggregate demand, which in this case was 200, multiply it by the multiplier, which was 2.5, and that will give you the change in income, which was this. So here it is. 200 times 2.5 is 500. Now the last thing I want to do before we move on to a more complicated problem is I'd like to discuss with you a moment how this multiplier works. So we're sitting here at equilibrium, right? Before we did all this green stuff, we're sitting here where aggregate demand equals aggregate supply. And then the first thing that happened was the government spent an extra $200 somehow, or they somehow stimulated businesses to spend 200 extra. So instead of being here where aggregate demand equals aggregate supply, we jumped up there. Can you see that aggregate demand is now greater than aggregate supply because we are above the 45-degree line? We're selling things faster than we're making it. And so what happens is production supervisors hire a few workers and they will move us over to here, right? Where again aggregate demand equals aggregate supply. But what happens when they hired those workers is they had to pay them. You could probably figure it out if you did this in Excel, how much extra income that was. And when you paid those extra workers all that extra income, they're going to go out and spend 60% of it, right? So when you paid these workers right here, they're going to spend 60% of it, which is going to move us back up here. Consumption is going to go up a little bit. And so aggregate demand is again greater than aggregate supply. So production supervisors hire a few more workers, and then of course they have to be paid, and it just goes on and on until we finally get to the new equilibrium over there. That feedback loop is the Keynesian multiplier, that each time you hire those workers end up spending a little bit of money, which further stimulates the economy, and on we go. Sometimes students call it a snowballing effect, which I guess is okay to think of it that way. Alright, so now there is another way to work this problem that's not visual, and you might like it better. So let's clean the screen a little bit. Now let's get some formulas down. So here are the formulas you need. You need the formula for the consumption function, right? You need this statement which describes Keynesian equilibrium, aggregate demand equals aggregate supply. You need this equation, that is the change in aggregate demand times the multiplier gives you the change in income. Alright, so the first thing to do whenever you want to work a Keynesian model problem without doing it visually, the first thing to do is to write out the equilibrium condition, that is aggregate demand equals aggregate supply. The second step is to substitute what this is, which of course is C plus I plus G plus XN equals income. Alright? Now the next thing to do is to realize, okay, in this particular problem there's no government spending, there's no net exports, so these two symbols are zero, they just disappear. And now consumption is this. Consumption is autonomous spending plus MPC times income. I didn't put brackets around it in the slide, but this little piece right here is consumption, then plus this little piece here is investment, that's obvious, and then there's nothing else because government spending and net exports are zero. Now the next thing I want to do is I want to grab these numbers and put them in here where they belong. So autonomous spending is 150, the marginal propensity to consume is 0.6 times income, investment is 250 equals Y. So the next thing to do is let's gather up these whole numbers. So I get 400 equals 0.6 times Y equals Y. Next thing I'm going to do is I'm going to subtract 0.6y from both sides. So now I have 400 equals, this is 1y minus 0.6y. So 1y minus 0.6y would be 0.4y. Then I'm going to divide both sides by this 0.4, and I get this. Equilibrium income is 1,000. Now notice I left this little space here. The reason I left that space is because it's really useful that to add this little step here. So instead of dividing both sides by 0.4 and getting this, take this 0.4 and push it over to the left side and write it like this. So it's 1 over 0.4 times 400. So all I did is I divided both sides by 0.4, but I didn't actually do the division over here. I just wrote it out. The reason this is helpful is because this thing right here, is the Keynesian multiplier. So 1 over 0.4 is 2.5, which is the Keynesian multiplier in this problem. That'll be really helpful later when we do a hard one. Alright, so now we have equilibrium income at 1,000, but notice we had full employment at 1,500. So we got a little problem. And we can solve this problem by using this formula. The change in aggregate demand times the multiplier gives you the change in income. So the change in income we need, right? We need to be at 1,500 and currently we're at 1,000. So the change in income we need is 500. The multiplier we already worked out was 2.5. So the change in aggregate demand times 2.5 equals 500. The change in aggregate demand is 200. If you go back about 5 or 6 slides, you'll see that that's right. The change in aggregate demand was 200. This is just another way of doing it, and the way we started was we just started with the equilibrium condition, aggregate demand equals aggregate supply. Alright, now we got to do a hard one. So this is going to be the full Keynesian math problem. Now I had to change this number. I left all the others the same, but I had to change this number because the other number was just too small. So let's add in government spending. Let government spending be 600. Now if we're going to have the government spend some money, they got to collect some taxes. So let's let the tax rate be 20%, right? Everybody's going to pay 20% of their income in taxes. And let's let imports be 50 plus 0.04 times YD. This looks complicated. You haven't seen this before. So the import function is modeled exactly like the regular consumption function, right? So this is regular consumption that you had before. So how much we import depends on some autonomous imports plus some marginal propensity to import times this. Now before you had Y, right? But that was before we had taxes. Once you introduce taxes, people don't spend based on their gross income. They spend based on their after-tax income. So how much we import depends on your after-tax income. That's this thing. YD stands for disposable income. That's your income after taxes. And then we needed exports. So exports are exogenous. There's that word again. So exports in the Keynesian model just depend on what foreigners buy from us. It doesn't depend on anything we do. Now there's one other adjustment. You see this consumption function that we had down here? That consumption function doesn't make any sense once we introduce taxes. If people have to pay taxes, their consumption depends on their after-tax income. So what I'm going to do is I'm going to modify this thing to represent taxes. So now consumption equals autonomous spending plus the marginal propensity to consume times disposable income. Okay, we're ready. Now I hope you can remember the first step was to just write out the equilibrium condition. Oh wait, I forgot. There's a couple more formulas down here. Disposable income is easy to understand. It's just your regular income minus your taxes, right? Disposable income is your regular income minus taxes. And taxes are easy to calculate. They're just equal to the tax rate, which in this case was 20%, times whatever your gross income was. Alright, so now we can get started. So let's take this equilibrium condition, aggregate demand equals aggregate supply. And the next thing, we're going to write what those are. So C plus I plus G plus XN equals Y. And now I'm going to carefully substitute all of this data in here. So consumption was 150 plus the marginal propensity consumed times YD. So this little piece right here is consumption. Plus investment is 250. There it is right there. Plus government spending was 600. There it is right there. Plus net exports. Now remember, what is the formula for net exports? It is exports minus imports. So exports were 400, that's where that came from, minus imports, and imports were 50 minus 0.04 YD. That's this thing right here. One more time now. Consumption plus investment plus government spending plus exports minus imports equals Y. Now the first thing I'm going to do is I'm going to gather up all these the first thing I'm going to do is I'm going to distribute this negative sign through these parentheses, because it's really easy for students to screw this up. So this negative sign goes on this and on that. So I'm distributing the negative signs. So now it looks like this, minus 50 and minus 0.04 YD. Now the next thing I'm going to do is I'm going to gather up all the whole numbers, right? 150 plus 250 plus 600 plus 400 minus 50. I get this number, plus 0.06 YD, that's that, minus 0.04 YD, that's this thing that's left over, equals Y. Now the next thing I'm going to do is I'm going to gather up these YD terms. So I have 1300 minus 0.56 YD. That is 0.6 minus 0.04, gives me that. Now notice that I'm kind of stuck. I got YD here and I have Y over there. So I'm going to come over in this little space and try to fix this. So from this problem that we're working out, taxes are equal to the tax rate, which was 20% times your gross income. And disposable income is equal to your gross income minus your taxes. So by substitution, I'm just going to put this here. So then YD is equal to 0.8 Y. Do you see how I did that? Your disposable income is equal to your gross income minus what you had to pay in taxes. And this is what you paid in taxes, 20% of your income. So disposable income is 80% of your gross income. Now I'm going to take this little number, 0.8Y, and I'm going to stick it in here because that's what I need, right? Disposable income is 0.8 times gross income. So on this line right here, I'm going to do that, right, 0.8Y. Now I'm going to do this distribution right here. So I get 1350 equals 0.448Y, right? See, I got rid of YD, now I'm in Y. Now I'm going to subtract this from both sides. So I get 1350 equals Y minus 0.448Y. Then I'm going to do this little arithmetic. So 1350 equals 0.552Y. Then I'm going to divide both sides by this, but I'm going to stick it over on the left, right? I'm going to leave it like this, times 1350 equals Y. And now in the last step, I can get equilibrium income is $2,445.65. So this is equilibrium income. But look here, full employment income was $3,000. So again, in the Keynesian world, we're stuck over here. Our economy is languishing here, but for everybody to have a job, we need to be over there. So this little thing is the Keynesian multiplier. So let's go ahead and figure that, right? This little thing, the Keynesian multiplier. So in this problem, the Keynesian multiplier is 1.8116. That's the multiplier. Now let's see if we can fix this problem. Equilibrium income is this small number, and we need it to be there. The way to fix it is to take this formula, the change in aggregate demand times the multiplier gives you the change in income. So I'm going to take that formula. Now the change in aggregate demand is the thing I'm trying to figure out. The multiplier is this thing, 1.8116. And the change in income I need to be there. And this is where I am at the moment. So the change in income is the difference between where I need to be and where I am. This is the change in income I'm looking for. So when you do that arithmetic, it just turns out to be 554.35. Then dividing both sides by the Keynesian multiplier, I get the change in aggregate demand is exactly $306. Exactly $306. And that, students, is how the Keynesian model works. It's really, it's at this level it's not too difficult, but those big university models that try to predict the economy, they're using the same fundamental ideas. The only difference between those big computerized models and what I'm teaching you is they have several more variables in theirs. But this is how it works, and there's always some multiplier. Okay, So now let's summarize what we've done here. The Keynesian model could be called the demand side model. Oh, I see a typo. Demand side model. It focuses on aggregate demand. Aggregate supply simply follows. The multiplier represents the feedback loop where a fraction of new income, that fraction of course is the marginal propensity to consume, a fraction of new income ends up as new consumption. So when those production supervisors hire those new workers get paid, and a fraction of their new income, in the problem we worked it was 60%, right? Wasn't it 0.6? Ends up as new consumption. And that new consumption contributes to additional aggregate demand. Keynesians believe that the economy can be steered with careful use of monetary and fiscal policy, and I haven't really spent any time on what these two things are, and that will come up in lesson 4, the last lesson. The Keynesian model is the most mathematical of the three models we study, and this follows logically since Keynesians are eager to steer the economy, right? And it is complicated, so they work really hard to find the precise way to steer it, and they are comfortable with aggregation. The Austrians, of course, would think this is really silly to try to steer it because these aggregated variables aren't very useful. Okay, so that's the Keynesian model. You should practice those two problems that I put out there to make sure you're comfortable doing that algebra. All right, hope you found this helpful.